This video will be the odd problems on page 11.5 and 11.6 in our notes. So we are going to look at adding and subtracting radicals. So far we have simplified radicals and then simplified radicals with variables. You will not have variables in these, it will just be numbers. So the first step, as you can see, is you have to simplify all of your radicals. That's always going to be the first step when we are doing any radical work, is you need to have them simplified. Once they are simplified, the same index means square root or cube root or whatever it might be. Ours will always be square root, so you won't have to worry about that. Same radicand means the same number underneath the square root side. So something I like to look at is if we do this in general. If we have a square root of b plus or minus c square root of b. Okay, so you have a number in front of your first square root and a number in front of your second square root, and you are adding or subtracting. The number under the square root has to be the same. So then you can just add or subtract whichever it says, the a and the c. So those two are considered like terms basically, and the square root of b just comes along, just like you would do if it were a variable. Okay, so for example, if I had 5x plus 8x, we know that that's 13x. So it's the same thing with the square roots. We're actually going to go down and do number 1 first, and then I'll go back to the example. So if you notice in number 1, the square root of 6 and the square root of 6 match. So then you just need to do what it says. 3 minus 2 is 1 square root of 6. Again, we don't ever need to write the 1 in this case, so our final answer is just square root of 6. You don't change it to the square root of 12 or anything like that. You only change the outside numbers if the inside numbers match. So if we go back up to the example, you can see that your inside numbers don't match. So we need to see if they will match by finding a perfect square that goes into 20. The perfect square that goes into 20 is 4. So this is 4 times 5. Square root, square root. The square root of 4 is 2. So I'm going to try to save us a little bit of time and not have to write it all out. So you have a negative 2 out in front, and maybe you don't even have to write that again. Square root of 4 becomes a 2. So negative 2 times 2 is negative 4 square root of 5. So our first term is negative 4 square root of 5 minus 2 square root of 5. So now that the square roots of 5 match, we just need to do negative 4 minus 2 to give us negative 6 square root of 5 for our final answer. So simplify the radicals. There will be some where your numbers underneath don't match. So those you'll just write as addition or subtraction problems when we get there. And then make sure you leave the number under the square root sign the same, and only the coefficients out in front are what change. So if we look down at number 3, 10 square root of 7 cannot be simplified, but the square root of 63 can. So 63, look at your perfect square list. 9 is your perfect square that goes into 63, 9 times 7. So square root, square root. To save us a little bit of work, this becomes a 3, and then we still have the 2 outside, so that needs to be multiplied. So that becomes 6 square root of 7. This 2 times the square root of 9 becomes 3, is how I got the 6. If you don't need to bring it down, the 10 square root of 7 down, that's great. If you do, just bring it straight down. So now we see that the 7's match, so 10 plus 6 is 16. Square root of 7 for your final answer. So you have to do all the work of simplifying before you can put the coefficients together. Number 5, 32 has a perfect square in it. It is 16. Again, some of you might think that, oh, 4 goes into 32, but that's not the biggest one. So we need to make this 16 times 2, square root, square root. Square root of 16 is 4. So we have 2 times 4 gives me 8 square root of 2 for my first term. So don't lose that 2 out in front. 2 times 4 gives me 8. 18. 9 times 2 is 18. 9 is our perfect square. Square root, square root. The square root of 9 is 3, and we also have this 3 right here. So 3 times 3 gives me 9. So bring down the minus sign, 9, square root of 2. So then we can just do 8 minus 9 is negative 1, square root of 2. So you don't need the 1, you just need the negative sign, square root of 2. Number 7, breaking down 160 would give us 16 times 10. Square root, square root. Square root of 16 is 4. So we have this negative 4 times this 4 gives us negative 16, and then the square root of 10. If you want to just right away bring down the minus sign, you can do that. 90 gets broken into 9 times 10. Square root, square root. Square root of 9 is 3. So 2 times 3 gives me 6, square root of 10. Negative 16 minus 6 gives me negative 22, and the square root of 10 just comes along. Now, if you look at number 9, you have 2 that match and 1 that doesn't. So this is where you're not going to be able to put all of them together. A good rule of thumb is if there's only 2 that you're adding or subtracting, you will be able to put them together. If there's 3 or more, you might not be able to put them all together. So as you can see, square root of 10 and square root of 10 match. We can't simplify those. There's no perfect squares that go in. So those 2 we can put together. So negative 2 minus 2 gives me negative 4 square root of 10. You cannot do anything but bring down the minus 3 square root of 6. So you might have more than one term for your final answer. Number 11, square root of 50, 25 is a perfect square that goes into 50 2 times. Square roots, square root of 25 is 5. So you have negative 3 times 5 gives us negative 15 square root of 2. Then I'm going to bring the plus sign down. 18 gets broken into 9 times 2. Square root, there's nothing out in front, so it just becomes 3 square root of 2. And then minus 3 square root of 3. If you don't feel like you need to bring that down in this step, that's fine. Just don't forget it at the end. So this one, you can put your first 2 terms together because their square roots match. That would give us negative 12 square root of 2, and then the minus 3 square root of 3 just has to come along. Number 13. All 3 of these have to be broken down. So 8 gets broken into 4 times 2, square root signs, square root of 4 is 2, negative 5, positive 2 gives us negative 10, square root of 2. Bring down the plus sign. 45 gets broken into 9 times 5, square root, square root. We have square root of 9 is 3. 2 times 3 gives me 6 square root of 5. 200 gets broken into 100 times 2. Square root, square root. Square root of 100 is 10. 3 times 10 is 30 square root of 2. So bring down the plus sign and then 30 square root of 2. So we can put the negative 10 and the 30 together to give us 20 square root of 2, and then the plus 6 square root of 5 comes along. Our last one, we have 5 and 7 under the square roots. Those can't be broken down, so we just need to match them up. This one, and this one all go together. So this is -1 minus 1 minus 2 gives us -4 square root of 5, and then the +3 square root of 7 needs to come along. And 17 is an application problem. So you need to remember that perimeter means all the way around. You're adding all the sides. So you're essentially doing exactly what we did up here in number 13. So you're just adding them all together. Some people like to write it out. Some of you can maybe simplify it off to the side. It's up to you. I'll go ahead and write it all out so you can see where it's all come from me. Okay, perimeter means add them all together. So 72 gets broken into 36 times 2. Square root, square root. Square root of 36 is 6. 2 times 6 gives me 12 square root of 2. 18 gets broken into 9 times 2. Square roots. Square root of 9 is 3, so we have 8. Sorry, I'll bring down the plus sign. 8 and 3 gives us 24 square root of 2. And then the 16 square root of 2 doesn't need to be simplified. So now we can put those all together because they have a square root of 2. So 12 plus 24 plus 16 gives me a total of 52 square root of 2. So again, you have to always break down the inside. Find the biggest perfect square that goes in. Anything that has a matching numbers under the square roots, you can put those coefficients together.